Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving an easy problem, merge sorted array. This is LeetCode 88 and the problem says you are given two integers array nums1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. It also says that the final sorted array should not be returned by the function but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the last m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So basically, if we can see the example 1, the question is just saying that nums1 exactly contains m elements, this which we have to deal with, and these extra zeros are nothing but these these are n zeros, which is the size of nums2, and we have to replace all these zeros with nums2 elements. uh, I mean, we have to shift all the nums2 elements in nums1 elements in place of these zeros such that the nums1 array gets sorted. So I hope you understood the question. The question, and let me tell you. So basically, in the nums1 array is given and nums2 is given, and nums1 initially has size m plus n. M his original elements which we have to deal with. N zeros are there. These n zeros will be replaced with these n elements of nums2. 256 will be there here. 256 will be in nums1 array such that this nums1 will have the size of m plus n and will be sorted. So the brute force idea which we can think of, we just replace all these zeros with all these elements in nums2. 256, replace these zeros with 2, 5 and 6, and then we can just sort the nums1 array. We can call the sort function, so this will be sorted. So this is the very brute force idea, but we don't have to do it uh, because this will take n log n time complexity also, and we have to do something better. So let's think about some better idea. So the better idea can be what we have: 1 2 3 0 0 0, and in the next we have 256. What we can do, if we want to do it in O of big O of n, what we can do, we can create a resultant array, let's say a result array of the same size m plus n. What we can do, we can just check which is smaller. We can use two pointer I and j, and we can just fill the smaller element here and keep moving I and j accordingly. Now 1 and 2, 1 will be there. Next 2, 2, 2 will be there. Next 2 will be there. Next 3 and 5, 3 will be there. Next 5 and next 6 will be there. So this way we will fill this array in big O of n time complexity, but the space complexity we can see here is also big O of n, because we are creating an extra array, we are taking extra size. But can you imagine, we can do this in no extra space. I mean, big O of 1 space complexity. How? Let's check. Let's think of it. We will figure it out anyhow. So the question was 1, the nums1 array was 1 2 3 triple 0, and the nums2 array was 2 5 6. Okay, now what do you think? The last element of the nums1 array, what we have to place here? What do you think? This will be obviously the largest element among the all elements we are given. So we are also given in the problem statement that these are sorted. These are sorted. So what do you think? How what we have to place here? We can just use two pointer technique, and here let's say this is, we can take I, and let's say we can take j, or we can just say this j is here m minus 1. Actually this was n minus 1, and we can say here I is m minus 1. What do you think? This will be obviously the max element, the largest element among these 2, 3 or 6. So we can just say here we will place 6, and we will also take a pointer here. Let's say this pointer as last. All right, now we have filled this last. Now we will move backward. Now it's time to fill this element, and we have here stored 6. We have used 6. Now we will move the j pointer backward, or we can just say we can decrease n also, because why to take another I and j if we are already given m and n, and we can use them. We can just say decrement m and n. So now for explaining I am just using j pointer. This will be easy to explain. Now what we can do, we can we are here now, our j is here now, 5 and 3. We will compare 5 and 3, which will be greater, 5. Now we will replace this with 5. This will be 5 now. Now L will move backward. Now j will also move backward. Now 2 and 3, which is greater 3. So this L element will be replaced with 3. I should use eraser. So this will be 3 now. Now our L is moved here, and this I is moved here now. Or we can just say we can decrement m, and we can call nums1 of m minus something, and nums1 of m minus nums1 of m, or whatever it is. I'm saying just instead of using I and j, we can just use m and n, and we can just keep decrementing it. In starting we can call nums1 of m minus 1, because we will take I pointer as m minus 1. So we can just call nums of m minus 1, and we will keep decrementing it accordingly. Now we who is greater, 2 or 2? Anyone. So we can just take anyone. So let's say I am replacing this 2. So in our L this will be 2. Now I will keep moving this pointer. This will be here now, I will be here, and L will be here now. Now which is greater, 1 or 2? 2. So we will place here 2. Alright, now L pointer will be here, and j is exhausted now. J has gone out of the boundary. So you must be thinking, now we have went out of the boundary, so what we will do in this case? But think of it, if this nums2 array is exhausted, and just nums1 has leftovers, so do we need to perform any operation? No, because we are asked to sort nums1 array, and nums1 array was already sorted. So we can see here 1 is already at its correct position, so we do not need to do anything. We can just return. Alright, but the second case, what if nums1 array get exhausted before nums2? So we have to handle the nums2 array also. So what if nums1 get exhausted first? What if m is equals to 0 and n is greater than 0? So nums1 will be exhausted. Now we have to handle the case, because all the there will be leftovers in nums2. So we have to obviously shift all the elements to nums1 array. So no problem, we will just call another while loop. We can just call another while loop for moving or shifting the elements of nums2 in the nums1 array. Alright, so now I will be going through the implementation part. So first of all, I will declare all the pointers. Let's say the last pointer will be the last element in the nums1 array. Now what I said, we will, our m pointer and n pointer will be here. Our m pointer will be at m-1 position. I mean, see, we were using 3 pointers. First was the last pointer, and another was another 2 were I and j. So our I will be at this m-1 position. So I'm not taking I, I'm just using m and n only, because we are already given m and n and we don't need another I or j pointer. So we will check if m is greater than 0 and if n is greater than 0. Now if nums, let's say what I said, the one will be greater, the one element who will be greater, we will replace that element or swap that element with the last index element. So if nums1 of m-1 is greater than nums2 of n-1, we will say in nums1 of last, just go and place the element which is greater, and here we got the greater element m-1, and we will not forget to move the pointers. We will decrement m and we will also decrement last pointer. Else case, if nums2 of n-1 is greater, so we will say nums1 of last will be nums2 of n-1, and yes, we will decrement n and our last similarly. And that edge case, when one of the array will be exhausted. So as I said, if nums1 is exhausted, so if nums1 is exhausted first, we are still left with nums2 elements, so we have to take care of that. So I will just call, if n is greater than 0, I mean if there are still leftovers in the nums2 array, so I will just call this and I will copy this case where nums1 of last will be nums2 of n-1. This will shift all the nums2 elements into the nums1 array. But what if nums2 get exhausted first? So we don't need to handle anything, because nums1 was already sorted and all the elements will be at its correct place. We have seen through dry run also. So now after doing this, we can see we have easily shifted all the nums2 elements into the nums1, replacing all the zeros carefully and making sure making the nums1 array sorted. So let's run the sample test cases first. Yes, we have passed all the sample test cases. Now let's submit it and check whether we are able to pass all the test cases. Yes, we are able to solve this problem successfully. And if I talk about the time and space complexity, so time complexity, we can say we are just using using a while loop which is checking all the elements. So we can say that time complexity is big of n plus m, and the space complexity, we are not using any extra space, so our space complexity is big of 1 array. We are not using any extra array or anything, just one last variable. This will take big of 1 space, and time complexity, we are just running while loop, and every element in any array is at most visited twice, and most of the times it's only once visited. So we can say this is time and space complexity. And also, if I tell you more about it, this question, merging sorted arrays, is a very common uh, pattern we can see while merging the arrays. In this we have learned that how we will manage the edge case if any of the array get exhausted while merging. So we have to handle the edge cases also, and we will, okay. So this is all for this problem, and thanks for watching. See you in the next video.